Welcome to Unit 3, Lesson 2, Chemical Reactions, Mastery Session. By the end of the session, you should be able to take Unit 3, Lesson 2, Assessment, and master that assessment. Let's get started. So, Unit Lesson 2 discusses chemical reactions. Let's think about how we heat our house. If you heat your house with propane, you are heating by a chemical reaction. So the propane reacts with oxygen to produce heat, carbon dioxide, and water. Reactants and products. Within every reaction, you have a set of reactants. Those are the things that combine, and you have a product. So those are things that are there after the reaction takes place. So when you turn on, let's think about those people that, maybe live in the country and heat their home with propane. So when you turn on a propane stove, propane reacts with the oxygen to form different compounds. The reactants are propane and oxygen. The products are carbon dioxide and water. So the process of breaking and forming bonds to create products occurs in a chemical reaction. Right? So we're breaking the bonds of this propane and oxygen. A chemical reaction occurs, and what's produced is carbon dioxide and water. The reactants have different properties than the products, right? So the propane and oxygen have different properties than the carbon dioxide and the water. The resulting products are different compounds than the reactants and have their own distinct properties. The properties of the reactants are different because a chemical bond has occurred. So there are two different types of reactions. There are exothermic and there are there's more than two. First, we're going to talk about exothermic and then endothermic. So exothermic reactions release energy. So they release more energy than is needed to get the reaction started. So if a reaction is releasing that energy, then it is called an exothermic reaction. For example, that propane and oxygen reaction, propane and oxygen gas need energy to react. They need a spark to get the reaction going. During that reaction, heat and light are released. Heat and light are forms of energy. If a chemical reaction occurs in a glass bowl and the bowl becomes warm, was the reaction exothermic? So what do you think? If we know the exothermic reaction releases energy, and let's pretend we are doing that reaction in a bowl, and the bowl got warm, would it be an exothermic reaction? Yes. The reaction is exothermic because it releases energy as heat. That is why your glass bowl would feel warm. Endothermic reactions. Some reactions need energy in order to keep them going. So they're not giving off, they're not releasing energy. They need energy in order to keep them going. Endothermic reactions absorb more energy from its surroundings than it releases. For example, when water is broken down into hydrogen gas, it requires energy to keep the reaction from stopping. The energy is absorbed to break down the water and form the products. This picture gives us a little better picture of an endothermic reaction. So you have the reactants on the bottom, all right? As the reaction takes place, you can see the amount of energy needed is going up, okay? That's energy needed, not given off. So heat is absorbed during this reaction, and then we have the products. Combustion reactions. Combustion is an exothermic reaction that occurs between a fuel and an oxidizing agent that produces energy, usually in the form of heat and light. All right, so combustion is an exothermic reaction. So a combustion reaction gives off energy. All right, let's take, for example, striking a match. So when you strike a match is never the same, so we know that it's a chemical reaction. but is it an exothermic or is it an endothermic? When you strike the match, energy is given off, energy in the form of heat and light. All right, so then we know it is an exothermic reaction. What makes it a combustion reaction is we are using a fuel and an oxidizing agent to produce that energy. In combustion, a compound reacts with oxygen, creating heat and light. Decomposition reaction. In a decomposition reaction, compounds are broken down into two or more simpler compounds. All right, so a decomposition reaction is not producing completely new products, but it is actually breaking down those reactants into more simpler compounds. For example, the decomposition of water. The water is broken down into hydrogen gas and oxygen gas. Let's take a look at a decomposition of water experiment. The on-screen picture shows the decomposition of water. The water is broken down into hydrogen gas and oxygen gas. You can see in the bottom of the beaker, there's water, all right? We are keeping this reaction going by the use of this battery. So we are putting energy into the reaction. Because of that, the water, H2O, is decomposing. It's breaking down into simpler products. So we have hydrogen gas and oxygen gas. All right, so those are the products of that reaction. This system is called electrolysis because the decomposition of water results from passing an electric current, we're using that battery, through water containing some ionic salt. So the reaction is called electrolysis. It is an endothermic reaction, we talked about that, because energy from the battery must continually be supplied for the reaction to take place. If we take this battery out, this isn't going to happen anymore. A decomposition reaction breaks down into two or more compounds. Precipitate. A substance that separates in the form of solid particles from a liquid is called a precipitate. So this is another chemical reaction. When the reactants, so precipitate is going, we're going to talk about this specific reaction, but I want you to know that any chemical reaction where a precipitate is formed is considered a chemical reaction. So when talking about this one specifically, the lead nitrate and potassium iodide combine in a chemical reaction. So the bonds in each reactant break down and new bonds are formed. The bright yellow color indicates that a chemical reaction has taken place. The bright yellow is due to the formation of solid lead iodide. So this substance in this beaker is not another liquid, but it actually forms a solid substance. That's why it's called a precipitate. So some of you might be thinking, all right, well, how do I know whether or not a chemical reaction has occurred? There are ways for you to say, maybe a chemical reaction has occurred. So a chemical reaction can result in precipitate being formed, so that was the slide we just discussed, in the formation of a gas, or, when we talked about the this one. So we had we know that a chemical reaction has occurred because two gases are formed. We know that a chemical reaction has occurred here because a precipitate was formed, or a change in color, all right? So these are indicators, and these are just indicators of a chemical reaction. They don't guarantee that a reaction has taken place, but if you see one of these changes when you mix chemicals, then that says to you, hey, a reaction may have occurred. We need to look into it and see whether or not it was a chemical reaction. So just because something happens does not mean a chemical reaction has occurred. So you've done your experiment, you're seeing gases are being released, you're seeing maybe precipitate form or a change in color, and so you're saying, has a chemical reaction occurred? So that's when you would look deeper into it. One way, that just because some of those things have happened does not mean a chemical reaction has occurred. So when you open up a soda bottle, fizz is released from that soda bottle. But a chemical, so that may be your, chance to say, hey, maybe a chemical reaction has occurred. But just because it happened does not mean that a chemical reaction has occurred, because the carbon dioxide gas was already in the soda bottle and it was just dissolved. Okay? Another one, so change in color when you combine yellow and blue to make green. The pigments yellow and blue make green, but no chemical reaction has actually taken place. No bonds were broken and new bonds formed. Okay, so that was Unit 3 Chemistry, Lesson 2 Chemical Reactions. Go ahead and take the assessment. If you do not pass the assessment, please contact me and let's set up a one-on-one session to dig into the information a little bit more. Good luck.